Okay, now we've seen a few different ways to manipulate arrays, but most of the ways we've worked with have been arithmetic or aggregation, so kind of performing calculations on NumPy arrays. Now, what if you needed to change the shape of your NumPy array? Now, why would you need to change the shape of a NumPy array? Well, remember, a lot of machine learning is lining up your inputs into a machine learning algorithm and making sure that they come out with the right output. One of those ways of lining up inputs is making sure your data or your list of numbers or your array of numbers is in the right shape. So let's have a look at how to do that in NumPy. So we'll go reshaping and transposing. This is this section. Nice little heading there. So let's have a look. A2 array, beautiful. Let's figure out what shape it is. 2 by 3, yep, that makes sense. Now, remember before in a previous video we tried to multiply A2 by A3. Let's visualize A3 so we can see it again. A3, there we go. Let's check out the shape. A3.shape. Okay, now what's going to happen if we try to multiply these? Operands could not be broadcast together with shapes 2, 3 or 2, 3, 3. Well, the beautiful thing about NumPy arrays is that they can be reshaped or transposed. Let's have a look at reshape first. So what does reshape do? Reshape is a method you can call on any array. So if we type in here, .reshape, shift tab, reshape docstring, returns an array containing the same data with a new shape. Beautiful. There we go, we've got some more information there. Let's see what it requires. Shape. So one of the rules of broadcasting, if we look up broadcasting one more time, one of the rules of broadcasting is here. General broadcasting rules. When operating on two arrays, NumPy compares their shapes element-wise. It starts with the trailing dimensions and works its way forward. Two dimensions are compatible when they are equal or one of them is 1. So what this means is that if the shapes of two arrays are equal, the multiplication can happen. But if they're not equal, one of them has to be 1. So that's what we're going to do here. We're going to reshape the A2 array from its shape 2, 3, incompatible here, and we're going to change one of these dimensions. We're going to add a dimension actually. So reshape 2, 3, 1. Let's see what happens. Okay, so it's shuffled our array around a bit. Let's print the shape here. So see our A2, we've used the reshape method, passed it a different shape. So now we've added another dimension here. And now its shape is 2, 3, 1. We'll check A3's shape. Okay, 2, 3, 3. So if we refer back to the rules of broadcasting, are the dimensions equal? No. Is one of them 1? Yes. So let's try this. A2, we'll make a variable, A2 reshape equals A2.reshape, 2, 3, 1. Beautiful. So we'll have a look at this. A2 reshape. There's our reshaped A2. A2 reshape times A3. There we go. Beautiful. So that is the benefit of reshape. Now this is only a small example here. Before they were incompatible, but because we reshaped it, we reshaped A2 to be within the broadcasting rules of NumPy, we could then use the multiplier function across these two arrays. Now, if this concept is kind of strange to begin with, that's perfectly fine, and it will be. It will take a fair bit of practice to figure out how to use reshape properly. But what the important takeaway here is that just because your NumPy array comes in a certain shape, like it begins like this, doesn't mean it has to stay in that shape. So this reshaped version of A2 still contains the same information as the original A2, it's just in a different shape. So this is one of the problems you'll come across in many different machine learning problems, is making sure that the data that you're trying to find patterns within is the same shape, so the machine learning algorithm can run over it, like this broadcasting operation, as quickly as possible. And if they aren't the same shape, you'll often get back errors like this, which say the data you're trying to find patterns in isn't the same shape. So that's when you have to figure out how to use something like Reshape to turn them into the same shape so that they're compatible with each other. Now, there's one more thing, which is transpose. Now, what transpose is, let's have a look at it first. Let's put a little comment here so we know what's happening. Transpose. A2, actually, we might leave it here, a2.t, so we can see what's changed here. Let's get A2 back up. A2's there. Transpose. What's changed? Let's go .shape. 3.2. Okay, now if we go here, A2.shape. So what a transpose does, it switches the axes. So now, A2 shape was 2.3, but if we call transpose, and now T is for transpose, it's going to swap the axes around. That's where we can see that now 1, 2, 3.3 is down here in the column, and 4, 5, 6.5 is on this column. So what it's done is essentially just swapped the rows and columns. Now you can do this on a larger array as well. Let's view A3, A3.shape, 2, 3, 3. So if we call A3.t, it's going to swap these axes around. So if let's see, A3.t.shape. So now we've essentially flipped it. So now this dimension, so 2 is right at the end, and 3 and 3 have swapped to the front. The important difference here between transpose and reshape is that transpose just flips the axes around, and reshape, you can create your own custom shapes. So for example, we reshaped A2 to be compatible with our broadcasting rules. So have a practice reshaping some of your arrays, and I'll see you in the next video.